Okay, I want to start with going over the physics formulas and explain why they're color-coded this way. I think it's best if you try to memorize them in groups, and I tried to make sense of the formulas and how they relate. So this group of formulas that are in purple are all formulas that have to do with resolution of your ultrasound image. So as we go through each individual chapter, and the different lectures, you're going to see the relationship that they have. But let me see if I can explain one thing. For example, okay, you're going to learn how changing the frequency is going to improve your resolution. So once we get to that formula, indirectly, if you were to increase your frequency, it's going to decrease your wavelength. And how is that related to resolution? Well, if you decrease your wavelength, your spatial pulse length is smaller, and your axial resolution numerical value is smaller, and that's improvement in the resolution of your image. So again, these formulas here are grouped together because they relate to one another. And again, this is ahead of where you're at, but just to give you an idea of why they're grouped this way, that's a basic explanation, and I'll show you as we continue in the program. So these are resolution grouped formulas. These formulas have to do with attenuation and penetration of the sound beam. Again, so they're all grouped in red, and this is a good way to memorize them. The next group in orange is formulas that have to do with propagating through tissue. And this isn't necessarily, the bottom one here isn't necessarily a formula, but it's a relationship. And what you should understand is that the speed is proportional to the stiffness or the bulk modulus. That means if there's an increase in stiffness, then the speed will also increase. Whereas anything below this line, if there's an increase in density, compressibility, or elasticity, that will have an inverse relationship to speed. So it's important that you understand relationships. For example, if we had A is equal to B times C over, let's just say, D and F, what that means is anything on the bottom, an inverse relationship with the isolated variable. And the isolated variable is always the one that stands alone on the equal sign. This is the one that has a relationship with all the others. They don't have a relationship with each other in this format. You would have to isolate a particular variable if you wanted to know the relationship it has with the others. So only the isolated one has a direct and indirect relationship with the other variables. For instance, anything on the top of the line, A has a direct relationship with. If B and C or one of them goes up, then A will go up. Whereas on the bottom, that's an indirect relationship. If D goes up, A goes down. If D goes down, A goes up. So it's important to understand, again, formulas and direct and indirect relationships. So again, these orange colored formulas have to do with how sound propagates through tissue. The green ones have to do with the frame rate. That is the amount of frames that are displayed per second. That gives an ultrasound image the appearance as if it's actually moving. The blue formulas have to do with Doppler. And then there's a few miscellaneous formulas. So the first thing I wanted you to make sure that you understood was how to use the formulas. And if there are more formulas in the book, you don't need to know them at this point. These are the most important ones for this class and for your registry.